everyone, my name is Ellesse and I'm part of the amazing STEM response team here at the University of Wolverhampton. Welcome to our maths catch-up sessions. In this session in particular, we'll be looking at statistics and probability. Now to start with, when you're doing statistics, you need to collect data. And there's many different ways of collecting data, which we'll go through now. You can collect data by doing a census. And a census is where you collect data from a whole group of people, from every individual person in that group. So the group is a key word called the population. And it's really important to remember that the census takes data from every single person in that population. So it gives a very accurate reading of the data you're trying to collect, but it is difficult and time consuming. So to save time, statisticians do something called a sample. And a sample is a selection of that population. It's an unbiased random selection, so you'll get an accurate representation of your data for that population. Now, some keywords to remember within your sampling. Sampling units are the usable data sets from that sample. So each piece of data out of that sample. And then your sampling frame is a full list of those sampling units. And just to really drive in the importance, when you're doing sampling, it has to be a random sample, as this will keep your data unbiased and it will be a true representation of the group. So when you're collecting your data, we can categorize it into two different types. You can get quantitative data and qualitative data. Quantitative data is your numerical data, so things that are measurable. If we use humans, for example, if I'm measuring the attributes of different humans, their height and their age is something that would be quantitative data, as I can measure it on a scale. Whereas qualitative data is data that is non-numerical or categorical. This is data that can't be measured, but rather can be observed. So again, for example, with humans, we can measure our height and our age, but we can't measure what colour clothing someone's wearing or what colour their hair is. For example, I can't put on a scale blonde hair, brown hair, red hair and pink hair. I can only use them as categories, as there's not a numerical scale to them. Looking further now into quantitative data, we can break this down into two more sections. We can have our discrete data, which is certain values within a particular range, or continuous data, which is any value in a range. So if we think about it, if we take the human example again and we look at foot size would be a discrete value. You can have foot sizes from average going from size 3 to size 12, for example, but you can't have a foot size of 50. So there is a certain range where that data stops. Whereas with continuous data, it can be any range, like temperature, for example. You can have from minus 100 up to 100 plus, and even further than that. So there's a whole scale of data that you can choose from. Now we're going to quickly look at averages. And we're going to recap some of the things you should have learned in your GCSEs, and then go on to averages in a bit more detail. So here are our averages. We have our mean, our median, our range and our mode. Again, just to recap, the mean of our data is all our data sets added up and divided by the total amount of data there. So if we look at this example I have here, I have 9 feet on my screen. So I would add up each foot measurement and then divide it by 9. And that would give me my mean. Our median is the middle number, so the middle foot length. As you can see here, this was 18 centimetres. The mode is our most common number. Again here, the most common foot length is 19 centimetres. And then finally, our range is the difference between the largest number and the smallest number. So in this case, it would be 20 centimetres, take away 15 centimetres, which would give us a range of 5 centimetres. Looking at the mean now in a bit further detail, you'll need to recognise these formulas for your A-level or BTEC math studies. So the X with the little bar across signifies the mean, and we pronounce this as X bar. That strange shape, like a triangle, is called a sigma, and that means the sum of. The X in our formula here stands for the data value, and the N stands for the total number of data values. So remembering our feet example just, in this formula, the X after the sigma would be the data value of all those feet added up, and then the N would be the number of total feet, which was 9. There is a way to work out a combined mean of two different data sets too, and this is a formula on the right. So again, you have your X bar, and then you have your formula, which is the total number of data sets multiplied by the mean, plus the total number of data sets for your second data set multiplied by the mean, and then divided by data set 1 and then data set 2. So we'll put that into practice now just so it makes a bit more sense visually. So here's a quick example. The mean set of 5 numbers is 20. The mean of another set of 7 numbers is 13. Using the formula on the page, try and work out the combined mean for both of these sets. So pause this video here and then press play when you think you've got the answer. So we have our X bar, which means the mean, and then we turn that formula into the values that we have already. So this would be 5 times 20 for the first lot of data, plus 7 times 13 for the second data set. And then we divide the total set of numbers for the first data set, so 5, plus that with the second data set numbers, 7. And that gives us simplified 191 divided by 12, which is then 15.92. Moving on now to probability. So the probability is how likely something is going to happen. So it goes from 0 to 1, 0 being it's totally impossible to happen, and 1 being 100% certain to happen. And different things that can happen are called outputs. Your sample space is all the possible outcomes, and the event matches one or more of those possible outcomes. So outcomes, sample space, and event are the key words in probability that you need to understand. So here's a quick example. A pond contains 30 fish. They're coloured blue, green, or yellow, and then they are tagged either A or B. Using the table below, find the probability that a fish selected at random is green. So what we would do, we would look at our table here, and we'd funnel down to get the answer of how many fish are green. So in total, there are 8 green fish, but overall, there's a total of 30 fish. So our probability would be that to get a green fish would be 8 over 30, or simplified 4 over 15. So here's one I want you to try yourself. Find the probability that a fish selected at random is blue or tagged A. Again, pause this video here and press play to see the answer. So first of all, we have to try and add up all our possible outcomes. So we can see that we have a total of 10 blue fish. And then when we looked at fish that are tagged A, we can see there's 3 green fish that are tagged A and 4 yellow fish that are tagged A. So we have to plus the combined total of blue fish, which is 10, plus green A fish, which is 3, plus yellow A fish, which is 4, which gives us a total of 17. And then we write that as 17 over 30, as 30 is the total amount of fish that we have. And that is a probability that we will pick a fish of one of these categories. You can also use Venn diagrams to find out probability. So here's a quick example of one that I made just. Find the probability that a random selected child goes to baking club. So in our Venn diagram, we have 2 circles. One circle is the amount of children that go to baking club, The other circle is the amount of children that go to singing club. Where they overlap, so where it says a value of 10, there are 10 children that go to both baking club and singing club. You'll see also that outside the circles in the square is a value of 15, and these are children that don't go to either baking or singing club. So to find the amount of children, or the probability of a child that goes to baking club, we first have to add up all the possible outcomes. So the outcomes here are that 15 children go to baking club and 10 go to both baking and singing club. So we add together 15 and 10 to create 25. If we then add up all those that go to baking club, singing club, both and no club, we get our total number of children, which is 60. So the probability that we'll choose a child that goes to baking club is 25 over 60, and simplified, which is 5 over 12. And we've done that using the formula below. So that's all we're going to touch on today in maths, statistics and probability. If you need to learn about some more statistical tests, you can check out our Biology Essential Maths, where we talk about chi-squared, t-tests, Spearman's rank coefficient, and the index of diversity. Thank you all for watching.